So hello guys, today we're gonna explain activity 3, which is enzymes, agents of digestion. First of all, we all know that enzymes are biological catalysts, okay? What do you mean by biological catalysts or biocatalysts? It means that these enzymes are catalysts that are present in our body. Okay, now let's see. What is a catalyst first? Let's explain what is the function of a catalyst. A catalyst is a substance that it may start a chemical reaction or it may speed it up. Let's see. Here we have, these are the reactants. As you can see here, these are the two reactants, the purple one and the orange ball, okay? Both are the reactants. This enzyme can join these two reactants and form a bond between them in order to form a new product. Okay, and this enzyme, it stays intact. شايفينه بقى مثل ما هو, it stays the same. Okay, and this enzyme also, or this catalyst, let's say, this catalyst, it can catalyze another reaction. It can go here and find another two reactants, and it can catalyze the reaction between these two reactants. So it is important to know that a catalyst, it speeds up a chemical reaction without it being itself involved in this reaction. يعني ما بيدخل بقلب الرياكشن. كرمال هيك دايما الكاتاليست إذا نحن عم نكتب الكيميكال رياكشن بنحط هون الرياكتنت, this reactant X, let's say, plus reactant Y, and then we will put the arrow here. We're gonna add the catalyst, okay? And here product 1 and product 2. So pay attention that a catalyst, it increase or speed up the chemical reaction without itself being involved in, and also it remains intact. يعني بيضل شكله ما بيتغير, and it can catalyze another reaction. Okay, so what is the relation of the catalyst with our lesson, which is enzymes? The relation is that enzymes are biological catalysts. يعني enzymes, they help the chemical digestion that occur in our body to occur. Okay, let's take example. Here we have starch and water. Starch and water, the starch will change to maltose under the effect of the enzyme, which is amylase. Okay, now let's look at the enzyme amylase. The enzyme amylase is gonna bind to the molecule of starch. This is the molecule of starch. It's gonna break the bonds here and it will form maltose. Okay, it will form a disaccharide without being itself intact, without being itself affected. So this enzyme, which is amylase, it can go to another starch molecule and it can hydrolyze it into disaccharides. So this is the activity of the enzyme. Now, let's see the major characteristics or the properties of the enzymes. What are the properties of the enzyme? First of all, the first property of enzyme, it is specificity. Specificity of the action of the enzyme on one substrate. What do we mean by this? We mean that each enzyme is specific to one substrate. Okay, we know many examples about this property. Let's say you know that lactase hydrolyze only lactose or aids in the degradation of lactose. You know that sucrase aids in the degradation of sucrose. You know that amylase is specific to starch. You know that pepsin is specific to protein. So all of these guys, each enzyme is specific to only one substrate. Okay, and as you can see here, the enzyme, it has a specific active site. This is the active site. This substrate gonna bond to this active site, and as you can see, it's gonna bond as if it is lock and key, مثل القفل والمفتاح. Okay, so it's gonna bind specifically to this active site. So if I have another molecule, let's say its shape is like this, this molecule cannot fit to this enzyme. So because of this enzyme can't degrade this molecule. Okay, so the first property I want you to memorize, that enzymes are specific. Each enzyme is specific to one substrate. Now, the second property is the enzyme, passes a maximum activity in a specific pH medium. What do we mean by a specific pH medium? pH, first of all, what is pH? pH, guys, it is a figure that shows us the acidity or the alkalinity, يعني the basicity of the solution. يعني it shows us if the solution is basic or acidic, okay? Or if it is neutral. If the pH is equal to 7, this means that the solution is neutral. If the pH is less than 7, okay, يعني between 7 and between 0 and 7, this means that the solution is acidic. And if the pH is greater than 7, which means that between 7 and 14, this means that the solution is basic, okay? Now we know that each enzyme is active at a specific pH. It is active at specific pH. Let's take examples. Salivary amylase, for example, it is found in our mouth. In our mouth, the pH is 7, okay? So the salivary amylase acts in a neutral medium, which is 7, okay? Pepsin, for example, which is found in our stomach. In our stomach, the pH is equal to 2. So pepsin acts in what? In an acidic medium, which is the pH is between 0 and 7. It is 2 in the stomach, okay? In the intestine, you know, we have many enzymes that are present in our intestine, like trypsin, sucrase, pancreatic amylase, maltase, lipase. All of these enzymes act at a basic medium. Look, the pH in the in our intestines is basic, okay? So all of these enzymes act in a basic medium, okay? So each enzyme, the second property, that each enzyme possesses a maximum activity in a specific medium, in a specific pH medium, okay? Some are active at a neutral medium, some are active at a basic medium, and others are active at an acidic medium. Now, the third property of the enzyme, that the enzyme has a maximum activity and at an optimal temperature. What is the optimal temperature? Let's see. This graph shows the activity of an enzyme as a function of temperature. So this is the activity of the enzyme on the y-axis, and this is the temperature on the x-axis. As you can see, the enzyme has a maximum activity between a temperature between 35 and 40 approximately, okay? So between these temperature, okay, the enzyme has a maximum activity, as you can see. So this, we name it the optimal temperature. We name this the optimal temperature between 35 and 40. And here it lies the 37, guys, which is the temperature of our body. Now, the important idea is that before this temperature, yani at low temperatures, the enzyme will be unable to function properly. Okay, will be unable to function properly. Why? Because molecule moves slower, okay, at low temperature, yani here between 0 and 30, okay? So the enzyme, as you can see, it has a lower activity. Now, but the thing that I want you to know, that if I put an enzyme at a low temperature, and then I move this enzyme and I put it at a higher temperature, the enzyme will be able to function again, okay? So at low temperature, the enzyme is inactive, but if I increase the temperature, it is still able to give more to be active again, okay? But if I put the enzyme at higher temperatures, like at 50 and 60 degrees Celsius, the enzyme at these high temperatures gonna denature. What do we mean by denature? Yani it will be destroyed. It's gonna be inactive for all its time, okay? It can't be active again. okay? It can't function anymore. It is denatured at this high temperature. So if I have an enzyme and I put this enzyme at a temperature of 60 degrees Celsius, and then I remove this enzyme from this solution, which has a temperature of 60 degrees Celsius, and then I put it again in a temperature, in a solution of temperature, let's say 37 degrees Celsius, this enzyme won't work. Why? Because this enzyme at 60 degree was destroyed. Okay, مات خلاص. Okay, now another property that enzymes need enough time to catalyze substrate. Okay, يعني it needs enough time. Let's say these are some examples. You have this picture with you. So let's say salivary amylase. This picture is on the bio guide. You can see it. So let's say salivary amylase. It has 15 minutes. It takes 15 minutes to catalyze the starch or to digest the starch. Gastric pepsin, it needs 60 minutes to digest the proteins. Pancreatic trypsin, it needs 60 minutes also to digest peptides. The lipase, it needs 90 minutes to digest the lipids. The pancreatic amylase, it needs 60 minutes to digest the starch. Okay, so every enzyme, it needs a specific time in order to catalyze the substrate. Okay, the substrate, guys, is the substance in which the enzyme is working on. يعني the substrate of salivary amylase. شو هي السبستريت للsalivary amylase؟ هي الستارش. اوكي، شو هي السبستريت للجاستريك بيبسين؟ هي البروتين، لانه الجاستريك بيبسين بيشتغل على البروتين. شو هي السبستريت للبنكرياتيك تريبسين؟ هي البيبتايدز، يعني البنكرياتيك تريبسين بيشتغل على البيبتايدز. This is what I mean by a substrate. Okay, now quantity، اخر property هي الكوانتيتي. مثل ما قلنا بالاول enzymes are biological catalysts، يعني they can work catalyst all in all, they can work in small quantities. Okay, so they speed up the reaction without being involved in it, and they can work in small quantities. Okay, so the enzymes, let's sum up all of these. So enzymes depends first, the enzyme's activity depends first on a substrate. As I told you, the enzyme is specific to one substrate. The pH, as I told you, some enzymes act on acidic pH, some enzyme acts on basic pH, and other acts on neutral pH. Temperature, the optimal temperature, it is between 35 degrees Celsius and 40 degrees Celsius. The time, every enzyme needs a specific time to digest the substrate, and the dose rate that the enzymes act in small quantities and they can work on large amount of substrates. Okay, now this this table, you can find it also on your booklet. As you can see, the enzyme, as I told you, it is a biological catalyst. It acts on a specific substrate. Let's see, the enzyme salivary amylase, it is found in our mouth. Okay, it acts on which substrate? What is the specific substance that it acts on? It acts on cooked starch, let's say. Okay, and it acts in a specific medium. What is the medium? It is pH equal to 7. Okay, what is the temperature? It is 37 degrees Celsius. So it's gonna change the starch into what? Into maltose. Okay, another example, pepsin, let's say, it is found in our stomach. The substrate that it works on it is protein. So pepsin, guys, it can't work on the cooked starch, let's say. Okay, the medium is an acidic medium, so pH is greater here, is less than 7. Pay attention. So pH is less than 7. For the pH of the stomach, it is between 2 and 3. Okay, and also the temperature, of course, it is 37 degrees Celsius is the temperature of our body. Okay, guys, so please study this very well, and I'm gonna see you on Wednesday.